This is the final lesson in chapter 20 in the GCSE textbook, and it's going to look specifically at conditional probability. This is something that we've come across before when we've been doing tree diagrams. We've seen when some of the probability has been conditional, but we're going to look at it in a little bit more detail. So two things we want to cover today. We want to be able to determine whether two events are independent by mathematically showing that they are independent. And then when we're looking at conditional probability, we want to be able to calculate it from tree diagrams. We've already done a bit of that, from two-way tables and also from Venn diagrams as well. Okay, so make sure you've got your exercise books out because you're going to need to make some notes on what's coming up now. Right, let's just remind ourselves about conditional probability. So what conditional probability is all about is it's where the probability of the next event depends on what happened previously. Okay, so if we think back to when we looked at our tree diagram examples, we did a tree diagram example where we took a counter out of a bag, we noted what its colour was, and we did not put it back. And then our second event was to take a second counter. Now you think about that. The probability of picking a particular colour for the second counter will depend on which counter we removed when we picked the first one, because there will be a different number of those coloured counters left. Okay, so that's what conditional probability is all about. If we took a counter and then we put it back in the bag, we're in the same situation where we take the second counter, so that would not be conditional probability. Okay, let's have a look at the terminology that we use for it. I did mention a little bit, I think, of this when we did tree diagrams, but let's just make sure we're happy with the terminology. Okay, so we've got two events A and B, and if we say what is the probability of B happening given that A has already happened, there's two different ways of writing it. This here is the way that you'll see written in the book, more of a wordy way, probability B given A. But this is also how it could be presented to you with this vertical line in the middle. Okay, and you would read that as the probability of B given A. So what that is, it's the probability of that event B happening given that event A has already happened. So back to our tree diagram again, it might be, what's the probability of picking a red counter given that the first counter I picked was also red, something like that. Okay, so what we're going to see in the examples that we're going to do, we're going to go through a few examples together, is to calculate the probability of B given A, what you do is you focus on the thing that's given. So you focus on the given A, and you make sure that for that event A, that's the only region on either the two-way table or the tree diagram. That's the only region that you focus on because it's given that that has happened. All right, so if you can do that, then you can just focus on those the region where event A has happened, and out of that you can see where event B then goes on and happens. Okay, I think it's easier to show in some examples. All right, before we get onto that, let's have a quick look. Okay, so let's have a look at independent events. We would have mentioned those before. If you remember what independent events are ones that do not affect each other. Okay, so the result of those events don't depend on what's happened before or what's happened after. Okay?
I'm here.
So that's my Siri kicking off there. So if A and B are independent, okay, we've come across this here before when we were looking at tree diagrams. Okay, so when they're independent events, if you want to do the probability of A and B, remember that there is and, if you want to do probability of A and B, then you do the probability of A times probability of B. So if you calculate those and they're the same, then that tells that they are independent events. Now this is the extra bit that we're going to have a look at today. Okay, to do with our conditional probability. So if two events are independent, then the probability of B, okay, will have the same value as the probability of B given A. And if you think that makes sense that that makes them independent, because if you work out what the probability of B was, then it shouldn't matter whether A has happened or not if they are independent events. So that's why if you calculate both of these and you find them to be equal to each other, then you can show that A and B are independent. Okay, so let's have a look at an example of that then. So you might want to pause this, but if you can write down the 2A table there, you see some information about accident claims for cars speeding or not speeding in wet and dry conditions. Okay, and the question says, are A and B independent? Give reasons for your answers. So what we're going to do, just to practice getting some information from 2A tables, we're going to calculate some probabilities. Okay, so first thing we're going to do is the probability of A. They've defined what they want A and B to be. Here they are. A is probability it's wet. Okay, so once you've drawn the table down, pause it if you need to. Have a look at the table. What would be the probability that it was wet? Well, we want to know how many wet ones altogether. 88 out of how many in total? 200. Okay, and that's 0.44. All right, so there's a decimal. All right, so that's the first one. Let's have a look at the probability of B, because we'll be having a look at these in a minute. So B, they've defined here the probability that it's speeding. So again, that's something, it's not conditional probability, that's something you should be able to look at that table and work out. What's the total of speeding? Look at the table, 32. Okay, out of 200, and that's 0.16. Okay, now here's the important bit. So we are now going to look at calculating conditional probability. So we need to look really carefully for this. So what I'm going to do first is I'm going to do the probability of A given B. So that's going to be the probability that it's wet given that the car was speeding. Okay, given that the car was speeding. Now, on the previous slide, we said what we want to do is we want to have a look at, so for this, we want to look at the probability of A happening, but only from the ones where B has happened. All right, so this is the important bit you need to understand. If you have conditional probability, if you have a given that, so given that speeding, you are focusing your attention on the table only within the speeding parts there. So all of the numbers that we use for our probability are just going to be from that section. Okay, so probability always how many out of how many. So we're only interested in the speeding ones because that's the given that. So total for speeding is 32. And then we want within those 32, how many were wet? And that was 11. Okay, so, which is 0.34375. So that is our conditional probability of probability that it's wet given that they were speeding. So you can see with that, what I've done is I've just looked at the speeding section of the table and I've done that, the total for that on the bottom. And then the top is which ones of those are wet. Okay, let's do the other conditional probability. Probability of B given A. So that's the probability of speeding given that it was wet. So again, right, what I want you to do is the given that is wet. So go to your table, find the numbers that relate to it being wet. So it's just those ones that we're interested in. What goes on the bottom? The total of all of the wet ones. So that's 88. What goes on the top? Well, we're only interested in out of those wet ones, which one was speeding. So that's going to be 11 out of 88, which is 0.125. We now have all of the information to decide whether A and B are independent. Okay, remember for independent, we would need the probability, doesn't matter which one you use, we would need probability of B given A to equal the probability of B. Okay, you could do the probability of A given B equal the probability of A. Let's have a look at our numbers that we've got here. Probability of B given A, 0.125. Probability of B, 0.16. They're not equal to each other, so they are not independent. or they are dependent events. Okay, and if we think about this within the context of the problem, okay, this one here is the probability of speeding given that it's wet. This one here is the overall probability of speeding. Okay, the probability of speeding given that it's wet was lower. Well, that makes sense, doesn't it? If it's wet, you're probably not going to speed as much, so that's going to be a lower probability. So within the context of the problem, it makes sense that they are dependent events. Look now at conditional probability on Venn diagrams. Okay, so pause the video, copy that Venn diagram down for me. Okay, let's have a look then. Part A. We are going to find the probability of A given B. So remember what we did before. The bit that was the given that, the B, that was where we focused on our diagram. So we are focusing on just these probabilities here, okay, because it's given B. So what goes on the bottom is the total of everything in B. So I'm going to do 0.3 plus 0.4. So that's the total of the probabilities for B. What goes on the top? I'm only interested in the ones that are in A. So I get 0.3 on the top. And again, you put that in your calculator. That one's best left as a fraction, okay, because sevenths are not nice as a decimal. So do you see what we've done there? The given that B, we focused on the B on the Venn diagram. So let's do the other one, B given A. So you think about which area I'm going to concentrate on the Venn diagram. Given A. So I'm going to concentrate just on the things in A. On the bottom, the total of what's in A. Okay, and on the top, what am I interested in? The ones that are in B as well. So that's going to be 0.3. So that's going to give me 3/5. Okay, so see what we've done there? As soon as it says given that, that's the area of the Venn diagram that we concentrate on. Okay, and on the bottom goes the total within that area. It might be probabilities, it might be numbers of things or that kind of thing. And then on the top is the bit that we're interested in. So it's only the things that are in B that are also in A. Okay, right. Okay, so on with this one again, pause it, copy it down, similar to what we did before. All right, so let's see if you understood what we did before when we were looking at those independent events. Okay, so two-way table, win, draw, lose, wet or dry. First couple of bits of the question, not really conditional probability. Probability that they won a match chosen at random. So we're going to have a look at how many matches did we win? 6 plus 17. Out of, we could add up all the numbers, but if you read the question at the top, it tells you it's out of 38. Okay. Leave it as a fraction, much nicer as a fraction, not particularly nice decimals. Okay. What's the probability that they won a match that was played in wet conditions? So we're on to conditional probability. Probability that they won given that it was wet. Okay. Haven't used the words given that. Okay. But the probability they won a match given that it was in wet conditions. Okay, so conditional probability, given that it's wet. So back to our table, which bits are given that it's wet? Those ones. Okay, so on the bottom goes the total of all of those. Okay, given that it's wet, just focusing on the wet ones. On the top, we want only the ones that we won. So we pop the 6 on the top, pop it in your calculator, you get half. Okay, so can you see what we're doing here? We're concentrating on the given that part of the table. Last part, what's the probability that they played the match in wet conditions given that they won? So we're going to do the probability that it was wet given that they won. Okay, so again, let's have a look. What's the given that bit? The given that bit is the bit given that they won. So this is the area of the table I'm concentrating on, this part here, okay? So on the bottom, the total in that part of the table, that's the given that they won. We're only interested in the ones that were wet, so that's the 6 on the top, and that gives you 6 out of 23. Okay, so it's all about concentrating on the area of the table that is the given that part for your conditional probability. Okay, last example we're going to have a look at then to do with tree diagrams and getting conditional probabilities off those. So pause the video, write this down. Right, you're going to need to write that tree diagram down. Okay, and that information down. Part A, draw and complete a tree diagram. Right, let's read it all. So we're talking about employees and the way they travel to work, and then we're talking about when they travel to work via that method, the probability they'll be later on time. So my tree diagram is going to have a branch for each of the ways they travel to work. So bus, train, car. Remember what we do? We write the probabilities on the branches, 1/3, 1/4. Pop it in your calculator if you can't do that in your head. We do 1 minus 1/3 minus 1/4, so that gives us 5/12. Off of each of these, okay, they can either be late or they can be not late. So we're going to have that of each of them, late and not late. And then we're going to fill in the probabilities for those from the information at the top, late and not late. Okay, so let's fill those in then. For the bus, those travelling by bus have a probability of 1/4 of being late. So 1/4 goes there. What goes here? Exactly right, 3/4. They need to add up to 1. Back to the question, those travel by train, probability of late 1/5. So not late 4/5. And those travel by car, probability of late 1/10, not late 9/10. These are kind of quite realistic figures probably, because you think if you go in your car, you've got a lot more control of being late or not late. So it's a lower probability of being late there. Good, right. What does it say? Draw and complete the tree diagram. Calculate the probability an employee chosen at random will be late. So let's pick out the probabilities from here that we're going to be late. So we've got bus and late. Remember what we do with tree diagrams? As we go along the branches, we times the probabilities together. Okay, so you can see I've gone along this branch and this branch, hence I've times those probabilities together. Okay, 1/12. I could write that one down, but I'm not interested in it, so I'm just going to write the probability of train and late, 1/4 times 1/5, 1/20. What's the other late one? Here it is, probability of car and late, 5/12 times 1/10, 5/120. Okay, so I want to find the probability that they can be late at all. Okay, so probability of any sort of late. Remember, if there's a number of different ways of being late, then what you do is you take those and you add them together. Showing our working. Okay, so we're putting together each of the different ways we can be late, bus, train or car, add them all together and we get 7/40. Okay, so we've done stuff like that before. Now we're going to get onto the conditional probability. So let's read part B carefully. Okay, calculate the probability that an employee who is late travels by bus. Now they haven't used the word given that, but can you see that they're saying we're only looking at the employees that are late? Okay, so that as conditional probability is the probability that they come on a bus given that they are late. Okay, happy with that? Right, so what we've done before, and it's exactly the same with tree diagrams, okay? We're only interested in the areas on the tree diagram where they were late, okay? And that is basically these three. If I'd written all of them out, they are the ones where they are late. So I'm only interested in out of these ones, okay? So that goes in my denominator. I can write them out separately. Let's write them out separately, just in case you hadn't done part A. We know what they add up to from part A, but I'm just going to write them out separately because on the bottom goes all of the probabilities for the given that. Okay. What goes on the top? I'm only interested in the ones that I've selected, that I've circled in red, the ones that I've selected that are to do with the bus as well. So I put 1/12 on top. Okay, pop that in your calculator. Okay, we get 1/12. Remember, the denominator we've already added up as 7/40. So that comes out as 10/21. Okay, so can you see with the conditional probabilities, the really important thing is, first of all, interpreting the question to make sure that you can see that they're asking conditional probability. And then secondly, look at the given that and only interest yourself in the parts of the diagram that's given to you or that you've drawn that have the given that in it. Okay, right, over to you then. So questions you're going to do from the textbook, it's 4 questions. All right, question 2 involves you drawing a Venn diagram. So I think it's a Venn diagram where you put some numbers in it and then you also put some probabilities in it. So draw it nice and clearly. And then there's a frequency tree for question 5. Remember, they're the same as tree diagrams, they just have numbers on that you can then use to calculate probabilities rather than have the actual probabilities written on them. Right, the Maths department is moving to all of Year 10 work being submitted on Teams as of this week. So a Teams assignment will appear, you'll get a prompt to do with that. So what you need to do is to do your answers, take photographs of them and upload them onto Teams. You can do that if you put the Teams app on your phone, you can do it that way, or you can just scan in and then upload them on the computer. It's really up to you. If you have any issues, get in touch with your teacher and they will talk you through it. Okay, if there was anything you weren't sure about, then go back and watch that part of the video again. Okay, thank you.